Hey everyone, happy Wednesday, and I am here today with you for the Math Wednesdays with the Learning Liaison. As always, I'd like to say I am the star host for tonight. Those of you who don't know me, I am Miss Pryia, and because this is my first time for the year seeing you guys, I wanted to say Happy New Year. I hope everybody had a great start to the new year. I know some of you are still like, ugh, math. Some of you are more like, it's not so bad. And the others are just kind of like here for the fun of it. I'm here for the fun of it. I know. I'm even wearing a math shirt today. It's a spooky one. It's about paranormal distributions. But hey, I'll wear any type of math shirt any time of the year. So let's get started. I don't have too much in store for us tonight, but I do have some good ones. So let's start off with question 1. It is a algebra problem. And the algebra problem here is to just solve, right? And we always talk to ourselves and see what they're really looking for. Well, here they're looking for whatever we can figure out. Based on our answer choices, we're looking for just a numerical value. Great thing about that is it's as easy as just figuring it out and solving it, right? If for whatever reason our answer choices didn't look as plain Jane or as simple as these, then we'd really have to figure something else out. But in this case, we don't have to. So what's the first thing that you guys notice that you want to start doing to the problem? Well, first thing here is you're gonna have to take it off your screen, make sure it's on your laminated sheet or piece of paper that you're provided with. And then once you write that out, you want to be sure of one thing. What you see is very different from what I'm about to write. Remember, the +6 is not under the radical. It is not within the square root. Okay, so when you write this out, you have to make sure you are very careful. That is the key here to the problem, is being careful when you rewrite it. Without rewriting this correctly, you will get a wrong answer. And I can show you what that would look like off to the side once we're finished solving it on our own. Right, so let's put this on over here. We'll do it wrong together. You know, that's one of my favorite things to do. So let's get started on the correct way to solve the problem, right? So first things first, what do we need to move from the side that we don't want anymore? And someone in the chat told us subtract 6 both sides. Love it, love it. So we're going to keep our radical or square root, keep everything inside of it, and 9 minus 6 is going to give us 3. All right, now here's the question of the day. How do I get rid of a square root? So square root, the opposite of square root, would be to square everything. Remember, what you do to one side, you have to do to both. So once we take the square of the square root, what's the cool thing that happens here? It goes away, right? So we'll be left with 2x plus 3. And then on the other end, we have to do what 3 squared is. And remember, 3 squared is the same as saying 3 times 3, because squares tell us, or the exponents tell us, whatever we have times itself. So whatever's inside that parentheses, we're going to multiply it twice to whatever we have. So 3 times 3 to give us 9. All right, now this is just a regular problem at this point, and you guys know what to do. Go ahead and subtract 3 to both sides. 2x is equal to 6. Last step, remember the 2 and the x are connected through multiplication. They're mushed up next to each other, so we have to do the opposite operation, which says we have to divide both sides by the number we don't want with the x anymore. So divide both sides by 2. X is equal to 3. And just like that, ladies and gentlemen, wham bam, thank you ma'am, you're welcome. Our answer is 3. All right, so you want to make sure that you get this right. And if you don't get it right, there's going to be a not so pretty answer that you're going to get. Now let's look at the wrong way to do this, right? Remember I talked about if you wrote this incorrectly and for whatever reason you put that 6 within the radical, it would look like this, right? And the first thing here now, instead of moving anything, we'd have to take the square of both sides. Not the square of, we'd have to square both sides. I apologize. Right, now when we square both sides, we will be left with 2x plus 3 plus 6 is equal to 9 squared. And 9 squared is 9 times 9, and 9 times 9 is 81. Now we're going to combine like terms on the left-hand side. And 3 plus 6 is 9. And we have 81 on the right-hand side. All right, now we need to subtract 9 on both sides. That'd be 80. Then minus 8 would be 72. 72? I'm a little brain dead. I apologize. It is. My calculator is failing me now, guys. 72! Yay! Yay me! Brain power works. Okay, so 2x is equal to 72. Okay, now we have to divide both sides by 2. And 2 goes into 7 3 times with 12, 36. Right? So it very much depends on what you do, depends on the answer you get. So you want to make sure, like I said, and I'll say it one more time, don't rush when you're writing your problems. If you rush, you can end up with the wrong answer, and the wrong answer sometimes is on there. Because you know what they love to do? Take into account that you did something wrong. And you're going to get 36, and you're going to look over there, and you're going to be like, oh, that's an answer choice. And you're going to select that, and it's going to be wrong. So just be careful. Right, you know what to do. If you have any questions, you put it in the chat. You let me know, because I always have that up. I'm always checking it. All right, question number 2. I'm just all about colors today. Question number 2 is a geometry problem. We can see it typically in middle or high school, right? And it's a problem that when you look at, you go, oh, it doesn't seem so bad, right? You see not too many words, then you look at the picture, and the picture seems pretty explanatory, right? It's nothing too much going, it's not much going on. Then you look at your answer choices. This is where it could get a little weird, because you're looking at these answer choices and you're seeing a lot going on. So what I always tell you guys to do is figure out what they're trying to tell you. So let's start by reading the problem. It says triangle GHI. So you want to make sure that you know where your triangle is. It is GHI. All right, great. We know our triangle is there. And they tell us the measure. That M with that alligator sign is the measure angle of HIG. And they tell you that it's 90 degrees. Okay, perfect. Well, we know it's 90 degrees, so let's go ahead and find it. So I'm going to go to my angle measure, and my angle measure right here is HIG. So just in case you didn't know how to read those, you start with the letter that you are first given, then you go to the second letter, and you go to the last letter. Wherever that angle is where your angle belongs. Well, 90 degrees is easy because they technically already drew it out for us, but it's okay. We're just learning some new things, so anyone who didn't know that now knows. Anytime you also see the perfect lovely square in an angle, it always means 90 degrees. Can anybody tell me another name for an angle that is 90 degrees? I should hear you all the way to New York yelling, right angle, it's a right angle. It is. 90-degree angles are also known as right angles. They also give you this lovely square. There's lots of stuff that we know about this, right? Lots of little things to help us know. So now they're asking us the question, which of the following is true? Now this is where a lot of you go, I don't know. Why does it have squares and not squares? And why is it plus and minuses? And someone totally said it in the comments. So if anybody else can see it, They know what they're talking about. And I'm going to write it down because it is exactly what they said. Because what's going on here? HI is what? Let's use a highlighter so we don't mess this up. HI is here, right? And that looks like something very specific. And GI is over here. And that looks like something pretty specific. And then they tell us about GH, which also looks like something very specific. And these specific things that I'm getting at is all of those are the legs or the sides of the triangle. Yes, the comments are going crazy and I love them. Yes, all of you are correct. It is the leg. So here is a leg. There is a leg. Everywhere we see legs. All right, so each of those things are legs. And someone said it earlier, and I get really excited when you guys know what you're talking about because I'm like, yay, it's working. To solve for the side or the leg of a right triangle, what do you need to know? Someone said it. It's Pythagorean's theorem. And everybody says it differently, and we're probably all wrong because we don't have Mr. Pythag here himself to help us out, right? So to remind you about the theorem, we know that a squared plus b squared is equal to c squared. I should probably write that away from the triangle because we're about to fill that in. So I'll write it again. A squared plus b squared is equal to c squared. Okay, now there's one thing that always matters, right? I'll tell you a hint, it's not A or B. It's always going to be C. C always matters. Why do I keep saying it? Because that is definitely the most important. C is going to be the lovely yellow side. And why does it matter so much? Use a different color. It matters because A and B are interchangeable. It doesn't matter how you plug those in. What matters is C. C is also known as your hypotenuse. If you don't plug C in for where C belongs, then you're going to get the problem wrong, right? Pythag himself, he came up with this. He figured it all out for us. So don't make it more difficult for yourself. It's already created. Use what we have. So now we go back to our answer choices and we realize first things first, A has a minus sign and it doesn't have a square at the end. So it's not what we're looking for. Then we go back again. And B tells us GI, which is here, which works. GH, which is here, doesn't work because that is our C, and C cannot be in the middle of the additions. Keep going. HI, HI is here. Then we have that squared, perfect. GI is here. We have that squared, perfect. And then we have GH, which is squared, which is what we're looking for. So we have C for winner, winner, chicken dinner. It feels good to say it for the new year. Winner, winner, chicken dinner. All right, you guys know what to do. Like always, have a question, put it in the comments, let me know. All right, number 3. It's an algebra/geometry problem. Why do I say both? Because it requires a little bit more thinking, right? It's not just a geometry problem, you still have some other stuff to do. So we look at the problem and we go, okay, they give us this lovely picture to look at. And the picture is what we're going to need to do all of this, right? So when we look at it, what are things that come to mind based on looking at the picture and just kind of glancing at the question? Let me know in the chat. What comes to mind when you see the question, the picture, and some of those words? What is that picture called? give you a hint. The lines are parallel. Yes, I do see that. The lines are parallel, but it has a very specific name. And the specific name starts with a T, and somebody said it. It's called a transversal. So the picture is a transversal. We know that it's a transversal. I could speak. We know it is a transversal because the little mini paragraph tells us some stuff. What does it tell us? It tells us in the figure to the right, kind of like right bottom, it works, that P and T are points on line K. All right, we can totally see that. P and T. Here's P, here's T, and they're on line K. Done. Then they tell us that points R, Q, and S are on line L. Well, we have Q, we have R, we have S. They're all on line L, which checks out. Perfect. Okay, now they tell us that lines K and L are parallel. That is the key to help us understand what's going on. If those lines are parallel, which they are, they have to tell you that they're parallel. Now that we know that they're parallel, they are cut by a line. That line makes it now a transversal, and transversals have lovely properties, properties that are great to know. So before we answer the question, I know some of you are like, please answer the question. Let's know some stuff. I didn't prepare for this one. So let's make our parallel lines. Here are our lovely parallel lines, and we're going to cut it with our line to make it a transversal. Here is the really cool thing about transversals. They have lovely properties. And if you know the properties, then you know how to answer the questions, right? So we're just going to number them to give us an understanding of what's going on. Okay, so now we're going to take a look at what different parts of this we're looking at. We have 1 and 4. Can anybody tell me what 1 and 4 are? They will be equal to each other, but there's a specific term for what they are called. Those angles are called vertical angles. They are across from each other, which means they are equal to one another, which says that they are called vertical angles. Same with 2 and 3, 5 and 8, 6 and 7. Okay, now let's go ahead and take a look at a different set of numbers. So I'm going to take a look at 2 and 6. Does anybody by chance know what type of numbers those are called? Starts with a C. They are corresponding angles. So angles that are on the same side of that cut line and on the same top or bottom of parallel lines, right? So 2 and 6 are to the right of the line that cuts them, and 2 and 6 are both on the top of the parallel line, so they are both corresponding. So 1 and 5 are corresponding. Cool thing. 3 and 7 are corresponding, and so is 4 and 8. Okay? Now, let's take a look at another type of number, like different types of numbers. Let's look at 3 and 6. Does anybody by chance know what 3 and 6 are? They're called alternate interior angles. So alternating means going from one side to the other, alternating. So we're alternating from that line that cuts everything, right? So we're on one side, which is the 3, and then we're on the other side, which is the 6, and then they have to be inside. That's what the interior means. They're kind of like spelling it out for you. So inside of the parallel lines means interior, so they're alternating interior, which also means 4 and 5 are alternating interiors. So can you go ahead and, before I get there, tell me what 1 and 8 are? Well, if they're on the outside of the parallel, what do you think they're called? They're called alternating exterior angles. I know, this is like so cool. It's so simple and so cool at the same time, right? So those angles are also equal to one another, which means that 2 and 7 are also alternating exterior angles, right? And then they also have the cool property to remember that any two angles that are next to each other and on a straight line will always form a straight angle to give you a total of 180 degrees. And we'll look at that right now to look at 5 and 7, right? 5 and 7 are on a straight line. I can highlight that line for you. There's the straight line that 5 and 7 are on. So 5 plus 7 will equal 180 degrees, which is also known as a straight angle. Right? So these are all things that you need to know about transversals. So now that we've gone off and we're going to go back to the problem, let's figure out what's going on. They want to know the measure of angle TRS. So we look at TRS and we go, okay, well, let's go to angle TRS. T, R, and then S. Well, I know right now TRS is equal to 8x plus 102 degrees. Now, based on what we just learned, can somebody go ahead and please tell me what that angle measurement is? Does anybody say that it's 110 degrees? Now, here's the thing. If you said it's 110 degrees, it's not. It's not. I know. How dare I? I tricked you. I'm sorry. But it's not 110 degrees. That's not the answer. Why? What happened? Okay, let's take a look. Let's zoom in on it so we can get a better idea of what's going on. Ready? Here we go. So we're looking at this angle, right? And TRS is right there. We've already kind of like drawn it out. So let's just kind of make it a little bit more predominant and do this. We already know it's 8x plus 102, so we're not really doing any harm there. But when we cut this, when we cut the two parallel lines by the transversal, there is our cut line, right? That's what's cutting our two parallel lines. The angle is not this angle here. What is the angle? The angle of that cut line is here. I drew a little bit too far. Hold on. Here. Why is it there? Because let's redraw it. Here's my first parallel line. Here's my second parallel line. Here's my cut line. I'll do my cut line in a different color. Here is 8x plus 102. Now over here, I have t. But this angle over here, I have 110 and 5x plus 10. That whole piece, I have that whole piece. I know, you guys are like, but it's 110. But it's not. It's not 110. It's 110 plus 5x plus 10. I know, tricky, Miss Pryia, how dare I? I know. It's like mind blown, right? It's not just 110. 110, so I'll just do this so we can see just a little bit more. Okay. Hold on, I'll have to put that all back. I'm sorry. Hold on, give me 1 second. Let's redo what we had. Here's our angle. Okay. Do you see how this line also cuts here? Well, when we redrew it at the bottom, do you see how that 5x plus 10 is a part of the original cut line that's over here? And if you don't see it, like I said, redraw it. it's this whole piece that we need to include, not just a piece of it. And to show you that it's just a piece of it, the 110 is literally just here. That is the 110, but the angle goes all the way down to the next parallel line. So we need to still keep going to the 5x plus 10. I know, I know, I know. I know, we're all mad now. Okay, well, let's unbe mad and let's finish solving the problem. So what do we need to do in order to be successful with the problem? We need to put it all together, right? 8x plus 102 degrees. That's for the TRS. And what is it equal to? It is equal to, ready? 5x plus 10 plus 110 degrees. You can put the degrees. The degrees just remind you that it's a degree answer. Right, so we're going to combine like terms on the right side. Keep what we have on the left side. 110 plus 10 gives us 120. I'm going to subtract 5x on both sides, right? Remember, we need to do the opposite of what we have. So we have a plus 5x, so we're going to subtract it, and we're going to get 3x plus 102 is equal to 120. All right, now we're almost there. We have to subtract 102 on both sides. I hope I don't run out of space. We're going to get 3x is equal to 18. 18, guys, 18. I got this. Almost there. Right, remember, the 3 and the x are connected through multiplication because they're mushed up next to each other. So we have to do the opposite, which tells us x is equal to 6 degrees. 6 degrees. Ooh, math is a little wonky for me tonight. Is that our answer? I know I boxed it. I have a bad habit of boxing. One, that's not our answer because it's not the answer twice. But two, what do we need to do? Do I need to plug it back into the 5x plus 10, or do I need to plug it into the 8x plus 102? Well, here's the thing. If you decide that you want to use the 5x, you have to use the 5x plus 10 plus 110. You can't just use one or the other. You have to use it in combination. And if you want to use the other side, you would do the 8x plus 102. I'm going to do it both ways just to show you that it doesn't matter, because I love to show you guys that you guys aren't crazy, that things really do work out the way that you think they do, right? So let's go with the easy one first, the 8x plus 102 degrees. We now know that x is equal to 6. So we will do 8 times 6, which is 48. Add it to 102, and we get a whopping total of 150 degrees. Now, for the non-crazy people, if you wanted to use the larger side, I think you're a little, you look for harder things to do. Remember, you want to condense it when you're on an exam, but if that's how you see it, that's okay, right? So let's go ahead and plug in 6 for x on that side. 5 times 6 plus 10 plus 110. Because remember, the entire angle is made up of all of that stuff. 5 times 6 is 30, plus 10 plus 110. 30 plus 10 is 40, plus 110, almost there, to give you the same lovely total of 150 degrees. And that, ladies and gentlemen, is Wham Bam Thank You Ma'am for the lovely answer. Okay, I know, I tricked you guys. I'm so sorry. Just a little bit, not completely sorry. But it's because if they do this to you, you have to know, you have to be able to identify them, right? So it's not just knowing this stuff. It's knowing this stuff and a little bit more. We should have known. We should have all known and see that coming, right? I did have a question about number 2, so I'm going to go back to number 2 really quickly, and then we're going to go on to number 4. Okay, here's number 2. So I use Pythagorean's theorem because we have a right triangle. The lovely right triangle tells us that in order to solve for the legs or the sides of the triangle, we have to use this theorem. This theorem has just been put into place. Pythag himself has figured it all out. He did all the hard work, so all we have to do is remember that anytime we're solving for the side or the leg of a right triangle, we will always use a squared plus b squared equals c squared. And then it's just remembering that c is always the hypotenuse, which is the diagonal or longest side of said triangle, right? So whatever triangle you're looking at, C is always going to be the largest, longest side, and it's always going to be the something plus something is equal to that. That is it. See, I do hold up my end of my promises. I do go back to problems. All right, number 4, probability and statistics. Some of you are like, I don't want to do this problem. It's not that bad. I promise. I know. Sometimes my promises are weird, right? Because I'll tell you that it's not that bad, and then some of you are like, this is really bad. So it says a whole bunch of stuff, and we see a table, and then we look at our answer choices, and what do we notice? All of our answer choices are decimals, right? Decimals are cool. I'm sorry, I don't know what's going on. Decimals are cool because we know that decimals come from some stuff, right? And we'll talk about that in a little bit, but that's to help get gears going. How are we going to solve the problem? So let's read it. It says, the table shows the distribution of 50 cookies sold at a bakery in one day based on flour type and topping. Okay, so we look at the table. They say, oh, look, all-purpose flour, cake flour, almond flour, total. Chocolate chip topping, sprinkles topping, total. All right. It says, what is the probability a randomly selected cookie is not made with cake flour? So we're going to take it one piece at a time. Not made with cake flour. So you can do this game where you go, not made with cake flour. So what type of flour is it made with? Well, if it's not cake, we're going to cross that off, which means that it could be all-purpose and it could be almond. Then we keep reading and it says, and does not have sprinkles as a topping. So that then tells us to go to sprinkles, and that's me crossing it off, okay? So now we're crossing that off. So now we have to ask ourselves, well, what are we left with? What are we really doing, right? How are we going to answer this question? Well, the only way to answer it would be to actually write it all out. And in order to do that, this is where I said your answer choices kind of help you. So a decimal. What's the form before the decimal? It's a fraction. And what's the form that you can make after the decimal? A percentage, right? So if our answers are in decimals, the thing that we need to do before the decimal is a fraction. So we have to create a fraction in this case, right? And probability and stats normally leads us to that, right? It kind of gives us a hint that fractions, decimals, percentages are just the things that we do, right? So if we're looking at this, we're going, okay, well, what type of fraction is it going to be? It's going to be a normal fraction with the part over the whole. Okay, so let's start with writing out in words our fraction and what it would look like. Remember, the part is the piece you're looking for. So the part over the whole, which is also known as the total, so let's rewrite that. The part we're solving for over the total. So what are we solving for in this case? We are solving for something that is not made of cake flour and something that does not have sprinkles. So what are we left with? Well, 13, 7, 28, 19, 19, and 50. Do we need all of those numbers? No, 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 we don't need all of those numbers. Remember, the totals are here. I'm not looking at that stuff because what we're doing is we're changing the totals by this new information, right? So essentially what we're doing is we're looking at all-purpose flour and almond flour, and because they're not sprinkles, they have to be chocolate chip. So the only numbers that are left are 13 and 7. Now, when they said total, they still meant the total of cookies from the entire batch. They just removed the types of cookies they didn't want to include in the random selection. Great thing about that is we're going to add them up and chug out a total. So 13 plus 7 is 20, and 50 and nothing else is 50. And then we have that cool rule that says that if zeros are at the end of numbers that are in fraction form, we can eliminate them, right? Because by default, what's happening is we're dividing by a divisible number of 10 or 20. I mean, not 10 or 20. 10, 100, 1,000, things like that, right? So we can take off those zeros to make it a little bit more biteable for us. And we're left with 2 over 5. Okay, well, 2 over 5 is not the decimal that I need, but I know that it's right along the way that I need to get there because I have my fraction. So let's take our fraction and turn it into a decimal. Those that have problems with turning fractions into decimals, it's very easy, I promise. You take your calculator and you literally type what you see. 2 divided by 5, and 2 divided by 5 is 0.4. Well, 0.4, but 0.4 is the same, right? So we have our winner, winner, chicken dinner over here. For B, 0.4. Okay, now what if they told you to turn that into a percentage? Let's say our answers were in percent form. Then we would multiply that by 100, which would give us 40%. And then another way to do it is to take the 0.4 and move the decimal and create swoopies. That is a technical term. 1 swoopie, 2 swoopies, to give you the percent of 40. Okay, so that's just in case we needed the percentage. But our answer is 0.4. All right, you guys know what to do. So the question if you have any. All right, here's a teacher question. I know, I had to do this. New year, new me. No, it's just new year, new stuff. So here's a teacher question. I know it's really long. So what's happening here is you guys get to this question on the test and you guys like freak out. Everybody freaks out when they see tons of words. So what we're going to do is take it in pieces. Take it piece by piece and see what's important and what we need from it. So let's start. Miss Gill graded a pop quiz and found many students had difficulty solving the following problem. Okay, they're about to tell us what the problem is. Marcy paid $9.10 for a shirt, including sales tax. The sales tax was 9%. What was the original price of the shirt before tax was added? That is it. That is all we need to know. That's the problem. Now, we go to the question itself. They tell us some information below this piece. This is important information. But now we have to piece through to see what we need from that. She wants to discuss 2 problems with a similar structure with her students during the next class and has already selected a problem for percent. So we're not looking for a percent problem, which is great because if we glance at our answer choices and we see percent is a part of it, we can eliminate it. It is a big fat no-go, right? She's already figured out that question. So we don't need a percent, which is great because it helps us get things out of the way. Then it proceeds to tell us which of the following problems involving fractions, so we're looking for something that involves a fraction, has a structure that is most similar to the structure of the problem on the pop quiz. Okay, so here's the thing about this. we can read each and every answer, which is great. But reading it doesn't always get us to where we need to be, right? Because I'm going to go ahead and say Rosie spends 3/8 of her monthly income on rent. If her rent is $1,200 per month, what is her monthly income? Bob feeds his parakeet 3/5 as much as he feeds his parrot. If Bob's birds share 20 ounces of food, how many ounces of food did Bob feed the parrot? Tom has 7/20 of his total monthly pay withheld for taxes. If his total pay last month was $926, how much was withheld? Will spent 60 minutes on his phone on Monday, which half was spent scrolling on social media. He spent 90 minutes on his phone on Tuesday, which 2/3 was spent scrolling on social media. How many total minutes did Will spend scrolling on social media those 2 days? I don't know. Reading the questions and the answers are not getting me any closer to where I need to be. Oh, I apologize. I copied the numbers wrong. My fingers have pressed 8 instead of 9. It doesn't change the problem though. So the best thing that we can do is put numbers to all these words, right? Let's create an equation, because if we're looking for a problem that is similar to what we've been provided with, which is Marcy's problem, then the best thing that we can do for ourselves would be to go ahead and actually write it out, because something is going to be similar to what we've already seen, right? So Marcy paid $9.10 for a shirt. That tells us the total, right? We know that's the total. So if that's the total, it's going to equal $9.10. Let me write it underneath instead of in the middle. And that includes what? It includes the sales tax that was added to the original price, right? So when we do percentages, think about it. How do you take the percentage of a shirt? You take the shirt and you multiply it by the percent, right? So now we have the shirt, and we have the shirt times 9%. Why did I write it like that? Because whatever the 9% of the shirt is has to be added to the original price of the shirt, which we don't know. So we could technically rewrite this as X plus X times 9%. And that's going to equal $9.10. That is what we're going to be looking for. So let's try Rosie. It says that Rosie spends 3/8 of her monthly income on rent. And her rent is a total of what? $1,200 per month. So that tells us that $1,200 is our total. Now what are we doing? We are doing what? Taking 3/8 of her income What's her income? I don't know. Let's name it X. So what is 3/8 of her income? We end up getting a problem that says 1,200 is equal to 3/8 times X. Does that look similar to the original problem that we had? No, nope, not at all. Nope. So let's try B. B says Bob feeds his parakeet 3/5 as much as he feeds his parrot. Okay, 3/5 of what? 3/5 of the parrot's amount. So let's name the parrot's amount X. And we have 3/5 of x and x to equal what? Our total here is 20 ounces because it says if Bob's birds, I got this. If Bob's birds share 20 ounces of food, how many ounces of food did Bob feed the parrot? Ready? 20 ounces, that's our total. Don't let these words scare you. It says that they share 20 ounces, so we know that much. Now, what do we have? We have the parrot amount, which we named X, and we have 3/5 of the parrot's amount. Right? Does that look correct? That looks correct to me because I have 20 as a total, and then I have whatever the parrot eats, and then whatever the parakeet eats. And remember, whatever the parakeet eats, it's 3/5 of the parrot's amount. So 3/5 times whatever the parrot eats, which is X. Now, does that look like what we need it to look like? It sure does, because we have X plus whatever times X is equal to our total, which is exactly what we're looking for. So here, our answer is B. Now I'm going to do C and D just so you can see what they would look like numerically, like if you have to keep writing them out, right? So if you did all of the answer choices, C now tells us Tim has 7/20 of his total monthly pay withheld from taxes. So if those are being withheld for taxes, then what else do we know? If his pay last month was $926, how much was withheld? Well, we know our total, right? Our total is 926, and that's equal to what? That's not how we write this one. I know, tricky. I tried to lie to you guys. 926 is not our total. It's our total from last month. And what do they do with how much he makes? They do 7/20 of that to keep for themselves. So instead of putting 926 as the total, we should write 926 times 7/20. Because whatever 7/20 of 926 is equal to X. Because the question is asking how much was withheld. X is our withheld amount. You could, if you wanted to, write it as, this would change how you write the problem. You could manipulate this and write this in any way, which means that you would end up with things in other forms, and it's just based on how you want to see it. But it should really be written as X is equal to 926 times 7/20. And the last one. This was 60 minutes, and half of that was spent scrolling on social media. So we have 60 times half, because half of that was spent on social media. That was Monday. And then we have Tuesday for 90 minutes, and 2/3 of that was spent on social media. And they wanted to know the total number of minutes. So we're looking for a total here, which is equal to X. This one does not look like anything like what we're trying to do, right? These are two parts that are being added together to solve for an X in minutes. But we don't know that from the original problem. The original problem, which is X plus X times the percent, is equal to the total. So B is definitely our answer. Remember, C and D are not, but I still gave you the equations for them, right? Now, just one more time, why it's B. We look at the question in blue, and it says Marcy paid a total of $9.10 for a shirt. And that $9.10 included what? It included sales tax. They told us that the sales tax is 9%. Based on the 9%, we know what? They then ask us the question, what was the original price of the shirt? Well, if the shirt is the shirt plus tax is equal to 910, which is the total of the shirt and the tax, then we can write it as X plus X times 9% is equal to $9.10. Now our goal is to find any answer choice that also yields the same type of equation. If it has the same type of equation, then we know that the equations are similar, which tells us what? That these are similar problems. Remember, Ms. Gill wants to make sure that her students are being able to find similar problems to help them, not just random problems to help them. And B, when we write it out, we know that Bob feeds his parakeet 3/5 as much as he feeds his parrot. Well, 3/5 of whatever he feeds his parrot plus his parrot eats a total of 20 ounces of food. So we know that 20 ounces is our total. Then we have whatever the parrot eats plus the parakeet. And remember, the parakeet is 3/5 times X, right? So it's making sure that you understand the question and how they're being worded to you. All right, number 6. Number 6 gives us this lovely graph, and then it tells us some information. And this is an algebra problem, and it's considered an algebra problem because of the coordinate plane. So the line shown on the coordinate plane is represented as y equals f of x, which is just telling us that it's a linear function. And it says, what is the value of f of 12 plus f of negative 12? What? So do I just plug in negative 12 and 12, and then I do 12 plus negative 12, and that's equal to 0? So is that my answer? No. That is not your answer at all. First things first, you need to figure out what's going on with this lovely line over here. And in order to do that, you have to be able to tell me what it is in a specific form. Does anybody by chance know what that form is? Y-intercept form. Yes, it is. Y is equal to mx plus b. Another way to write this would be f of x is equal to mx plus b, and they are both exactly the same. Now, m in our case is our slope. Slope is considered rise over run. And our b for boy in this case is our y-intercept. Those who don't know what a y-intercept is, in football, if you intercept something, you get in between you and that ball, right? You intercept the ball, you get in between you and the player. So this is where the line intercepts the y-axis. It goes through the y-axis, which will be exactly there. So before we even do anything, we already know that our y-intercept is going to be b. So let's go ahead and write our new equation with what we know. F of x or y is equal to, I don't know my m yet, x plus 3. Okay, now here's my question. Is the slope of the line negative or positive? I have this cool little way to help us figure this out. I know, I'm just like drawing through everything. That lovely letter that I just made is an N. N for negative. So we know that our slope is negative. And if for whatever reason it went the opposite direction, I'll go ahead and draw my lines. That doesn't make an N at all, right? We all see that. That doesn't make an N. So that is not a negative slope. That will be a positive slope. So right now we know that our slope is going to be negative. So we can do one of two things here. We can take 2 points that are exactly on lines and do the slope formula for 2 points, or we can count based on rise over run. When I say rise over run, you have to remember that rise can also fall. So it's up or down and then right. So if we did rise over run, we by default can start here at this 3, and we would rise to that 3 here. So we go 1, 2, 3, and we would run negatively. So we would go in the negative direction. So we go up, then we go in the negative direction, and we'd get -3 to get to this lovely blue point. Well, 3 over -3 is equal to -1, so our slope is -1 or -x. Okay, now that we have our slope, it is easy to see the next part of the problem. They tell us that f of 12 plus f of -12 is equal to what? We have to figure that value out. Well, remember, I've been writing it like this, which is a little unconventional to help you see what you need to. So we know that our x values are 12 and -12. So why wouldn't we plug in our values to figure out what we need? So I'm going to do this one in purple. And then I'm going to do this one in this lovely peachy salmon color that I have. So when I plug in 12 for my x, I'll get -12 plus, let me rewrite it in a different way, -12 plus 3, keep my plus sign, and then I'll have -12 plus 3. All right, now the first part, the purple part, -12 stays -12, add 3, and we get -9. Keep my plus, keep my plus. My negative becomes a +12 plus 3, which is 15, to give us a lovely answer of 6. All right? So they're not too bad. Once you know what's going on, you can figure out where you need to be. You can figure out how to get there. All right, our time is pretty much up. We definitely do not have time to, oh, we do have time to do the last problem. It is like literally 1 minute problem. I almost lied to you. Totally not lying to you right now. All right, so this is knowledge of groups. So if you understand what these look like, you will understand the question. So question number 7 gives us these 2 dots. They have dots that are grouped together, and it asks us, based on the pictures above, which choice would best describe the picture? I'll tell you right now, it's not memorization or grouping. It should and will always be, in this case, subitizing. So why am I telling you that it's subitizing, not unitizing? Because I defined it on the next one. Unitizing is this part to the left. Understanding that every quantity we measure is relative to another pre-measured group, right? So here we have 4 groups. Oops, that's not how you spell groups. Groups of 3. And over here we have subitizing. I know that this is 6, 4, 2, 1, 3, and 5. I can tell you that without counting them. That's the key for subitizing, right? And now we're almost out of time, so I'm going to hurry up and get to the end and say thank you for everything that you ever do, and thank you for showing up. The Learning Liaison has one-on-one tutoring, and we have lovely boot camps, and I can't wait to see you next week. Bye, everyone. I know, rushy rush.